Welcome to the future of factory automation.
Good to be here.
And just so everyone knows, this program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
That's right.
So today, we're really diving deep into a fantastic question. It came from a listener.
Yes, the documentation question.
Exactly. Documentation in PLC programming for factory automation. It's a really vital topic now.
Especially in Japan, right? With the aging workforce and, well, the shortage of FA control experts.
Absolutely. And Akra brought up a good point. He sees how in IT, they often have tools that just automatically generate documentation.
From the code comments.
Yeah. And he's basically asking, why isn't that standard in FA? Do we just not need it as much?
It's a fair question, and one that needs more than just a quick answer.
Totally. We're going to unpack this properly, really
Yeah.
get into the weeds for you.
Sounds good. So maybe I can start with my own take.
Please do.
For me, documentation isn't like an optional extra. It's core to writing the code itself.
Right from the beginning.
Absolutely. I document everything I make, explanations for function blocks, how the whole program hangs together.
What else?
Oh, screenshots are useful. Pictures of the actual machine sometimes,
For context.
Exactly. Partly it's for me, honestly. You forget stuff surprisingly fast.
Tell me about it.
But really, it's for the next person. Maintenance guys, production engineers, they need to understand it.
Makes sense.
So that means comments in the program, comments for devices, the
Yeah.
works. In IT, you wouldn't dream of skipping this.
And you think it's just as vital in FA? Maybe more so.
I really do. Downtime in a factory? It's a huge deal. Good documentation helps prevent that or fix it faster.
Oh, definitely. I mean, trying to understand a PLC program with zero comments, it's painful.
It really is.
I remember a job where we were upgrading these old Siemens S7 300s.
Okay.
And some of them, the commenting features back then weren't great. So you'd pull the code, and it was just raw.
Yeah.
Instruction list.
Oof. Like assembly language, basically. Exactly. Trying to reverse engineer that logic without comments. It took forever.
I bet. Adds cost, adds time.
Huge amounts. So yeah, from the ground level, if you're a plant engineer or integrator or whatever, those comments are gold.
Yeah.
Pure gold.
Mhm.
But you think this level of care is standard practice across the board?
Honestly, probably not as much as it should be, but it should be.
Okay, so back to Angel's question. This idea of auto-generating docs from comments, like they do in IT.
Right.
Why isn't that the standard approach in FA, especially with ladder logic still being so dominant?
Yeah, that's where it gets tricky. It's a key difference.
How so?
Well, even if you comment every single rung, every element perfectly,
Yeah.
understanding the overall flow of the process from just the ladder logic, that can still be really, really hard.
Because of how ladder itself works?
I think so, yeah. Think about text-based code, C++, at Python, whatever. It usually runs top to bottom, right?
Sequentially, yeah. Like following a recipe.
Exactly.
Yeah.
Step 1, step 2, step 3. Ladder logic.
Mm.
It's not like that.
It-
Right. It feels more like a bunch of electrical circuits all live at the same time. Or maybe event-driven blocks.
That's a good way to put it. It's like they're all being evaluated constantly, in parallel.
So it's not like rung 1 finishes, then rung 2 starts.
Not in that neat linear way. It's more like conditions are being checked all the time. If this condition is true now, then do this action.
Okay. Simultaneous assessment.
Pretty much. And that inherent parallelism, it makes it tough to see the big picture just from the individual rungs, even commented ones.
So you know what that specific line does thanks to the comment.
Right.
But piecing together how all those lines interact to control the whole machine, that's the challenge.
Precisely. Which is why the other documentation becomes so critical.
You mean like the machine specifications, the overall operating documents?
Exactly. The documents that describe how the machine is supposed to behave. That often tells you more about the why than the code comments alone.
That makes sense. The blueprint is more important than just notes on the finished structure, in a way.
Yeah. And this leads to a bit of a philosophical debate sometimes.
Oh, with who?
Well, especially if you talk to people at the PLC companies themselves.
Okay.
You sometimes hear the argument, look, the code is the reality. It's what's actually running.
Why bother with separate docs?
Sort of. Their point is, if the documentation says one thing but the code does another, well, the code is what's physically happening. So the code is the truth.
I mean, I can see that logic. If the machine's running, the code is making it run.
Sure.
But what happens when it stops running correctly? Or you need to change something? Or just figure out why it was programmed a certain way?
Exactly. That's where documentation saves you.
So what's the counter to that code is truth idea.
Well, one approach is to try and make the code itself the documentation.
But just having amazing comments.
Kind of.
Yeah.
Super detailed comments, maybe standardized formats, and then perhaps using tools to visualize that commented code better. The idea is the code becomes self-sufficient.
Okay, that sounds nice in theory.
Right.
But factory automation isn't always forgiving, is it? We're talking about production lines.
Right. It's not best effort.
If one machine bottlenecks, the whole line can suffer. Huge costs. So those initial specs, cycle time, operation, all those conditions, they're usually super strict.
And that's the critical difference. In FA, if the machine doesn't meet the spec, the machine is considered wrong, not just the code.
Right. The spec is king.
Absolutely. It has to hit that cycle time, make the right part reliably. If it doesn't, saying, well, the code is running, doesn't cut it.
Which brings us back to needing that documentation before you even write the code.
Exactly. Flowcharts, operational descriptions, outlining what it needs to do.
That's the guide for writing the PLC program.
Right. So trying to generate docs from the code afterwards, it kind of misses the point if the code might not even perfectly match the original intent or spec anyway.
The initial plan, the blueprint, that's where the real value lies for understanding the why.
I believe so. And there's another big piece to this puzzle.
What's that?
Hardware, the physical stuff.
How does that factor in?
It has a huge influence in FA, much more than in a lot of pure software development.
Yeah, okay.
See, in IT, you often have loads of flexibility. Need more power, spin up more servers, need more storage, add it. Factory hardware. It's not like that. It imposes real, hard constraints.
Right, you can't just easily swap out motors or sensors on a whim.
Exactly. And that's another reason why generating docs from the code is seen as maybe less practical or central here.
Because the hardware choices made early on already dictate so much.
Precisely. The specific PLC, the drives, the I/O, they're chosen for the job.
Yeah.
And their limitations often shape how the software has to be written.
So it's less software first and more.
More hardware defines the boundaries, now write software to fit. In many cases, at least currently. You have this fixed physical system, now make it work.
That makes total sense. The physical plant is a massive investment. You don't change it lightly.
But things are shifting a bit.
How so?
We are seeing more no-code and low-code platforms starting to appear in the FA space.
Okay. I've heard about that trend.
And that could definitely change how control logic gets created and potentially documented. It might open the door for different people to get involved.
Based on those clear specifications we talked about.
Exactly.
So the idea isn't necessarily that someone with zero technical background suddenly programs a complex robot cell.
Probably not. No, it's more about empowering people with other relevant expertise.
Like who?
Like maybe the mechanical designer who knows the machine inside out, or the production engineer who understands the process flow intimately.
Letting them handle some of the more straightforward control logic based on clear rules.
That's the idea. Democratizing it a bit, maybe. For those who understand the what and why, even if they aren't hardcore PLC programmers, still need solid specs and safety, of course.
Always. Which kind of leads to that provocative idea mentioned in our prep, this hardware's garbage concept.
Yes. The software eats the world argument.
What does it really mean for FA? Have PLCs reached that point? Are they just commodities now?
It's a really interesting idea, right? Often pops up when people see how dominant software platforms have become elsewhere.
Like with phones or PCs?
Exactly. The core idea is, as software gets super powerful, flexible, constantly improving, the physical box it runs on becomes less important, almost disposable in a way.
Like my phone.
Yeah.
The hardware is essential, but it's the OS and the apps that really define the experience for me. The brand of the chip inside. Less critical.
Precisely. So has that happened in FA? Are PLCs just boxes waiting for the real value from software?
Well,
Are they?
I'd say not quite yet, no.
Why not? What needs to happen first?
Well, for that hardware is garbage thing to really take hold in FA, a few things probably need to change quite dramatically.
Such as?
Hardware would need to get way cheaper, more modular, and improve much faster, like consumer gadgets do.
But FA hardware has tough jobs, right? High-speed motion, safety.
Exactly. Those performance needs, especially things like synchronized multi-axis control, tend to keep the hardware specialized and, well, relatively expensive compared to generic computers. What about industrial PCs then? IPCs. They seem more software flexible.
They definitely are, and they're getting used more and more. They have more processing power, can run more varied software.
So could they be the Trojan horse for software dominance?
Potentially. But For IPCs to really push dedicated PLCs aside across the board, the software running on them needs to offer massively more value.
How much more?
Like maybe 4 or 5 times the value people feel they get from a traditional PLC for core control tasks right now. Just say collecting data and sending it to the cloud. That's useful, but it's not enough on its own to make everyone ditch reliable, real-time PLC hardware for critical control.
So we're kind of waiting for a software breakthrough, a real killer app for FA.
I think that's a good way to put it. It could be a totally new system architecture, a new way of programming and managing industrial systems. Something that just changes the game.
And these things can happen fast sometimes.
They can. Look at AI recently. Things can shift unexpectedly.
It's also interesting how the big PLC makers are blurring the lines themselves now, isn't it?
How do you mean?
Putting PC tech inside their controllers. The difference between a high-end PLC and an IPC. Sometimes it feels like it's just the operating system and the marketing.
That's a very sharp point. The raw hardware capabilities are converging. The lines are definitely blurry.
Which raises the question, who leads the software revolution?
Exactly. Will it be the established players, maybe the big Japanese companies, or will overseas firms dominate that next software wave?
Is there concern about that in the Japanese industry?
There's definitely discussion, a feeling of needing to be at the forefront of that software shift. Absolutely.
So, summing up, hardware is getting better and better, but the real future hinges on a big leap in software value and capability.
I think that captures it well. And it circles back to Inez's question. For now, because of those hardware realities and how critical production is, good upfront specs and documentation are still absolutely vital.
More vital maybe than trying to generate docs from ladder logic after the fact.
Given ladder's nature, yeah. The IT approach has merits, but faces real hurdles in FA.
So the future probably does involve software becoming much more central, maybe even leading to that hardware as garbage point eventually.
But it needs that big jump in software value first, more than just incremental improvements.
And as question hits on something fundamental about where the industry is going, especially with workforce changes and needing to, spread the skills around more.
Absolutely. Which leaves us with a final thought for you, the listener.
Go on.
What is that killer app? What kind of system or software could truly revolutionize factory automation? What would deliver that 4x or 5x value increase that makes the hardware underneath less critical?
Yeah, what could that look like?
Think about the possibilities and what that shift would mean for the whole industry. Something to mull over.